actually going to set this up. So I've set this up so that it should look to you the way it will go in the actual investigation. Now, in the Qcat, it does say that you can do this activity with the students in groups. If you have the resources to do that and you're confident with your kids working and doing fair testing around that, by all means go for it. What I would say though is, if you do it in groups, always have some stuff set aside so that you do it at the end. Because unless you've done it a couple of times and tried it, which I have, there's a lot that can go wrong with this investigation. So, like I say, if you want to let your kids have a go, that's great, but be prepared for some groups to have something happen that is unexpected, it's not going to work for them, but then you're prepared, you can say, okay, everybody come over here, this is what it should have looked like. Not perfect science, but you know, we want the kids to have that visual to follow on with what comes next in the Qcat. So I've set up my cups. The blue cups, of course, are the tap water. The red cups are going to be the hotter water. Now, one of those cups I'm going to use boiling water. If you're doing this with groups, obviously you wouldn't give kids boiling water. Big safety no-no there. But because I'm doing it as a teach demo, I'm happy to have that. It is good, these are things that I have learned from bitter experience, it is good to test the cup with the boiling water before you try it, because some plastic is so thin that it will actually melt and warp, and that is not good. So, I've tried this already, and I know that this cup will be alright. So that's boiled water. Filled it up to about the same level as the other cup, talking to the kids about controlling my variables. Now the second cup, we want it to be hotter than the tap water, but not as hot as that. So I'm just going to add a little bit of tap water into there. About a half-half ratio should work for what we want to do. And then pour in my boiled water, and we're good to go. So you're saying to the kids, here we've got tap water, boiled water, tap water, warm water, tap water, tap water. Right, now I've got my food containers over here. Now I've already pre-filled those. They actually say to do that in the Qcat so that you allow the water to settle. So as carefully as possible, putting these onto the cups, and you might have to manipulate the cups around a little bit to make sure that they rest evenly. So 1, 2, and on that container over there I can already see condensation forming on that bottom cup because of the steam. That's great, get those two. So I've got my containers there, they're resting so that the water is settled. Next thing I'm going to do is set up my food colouring. Now the first time I tried this, I actually did it with pure food colouring. I just put the food colouring in a cup and used something like this to suck it up, put it into the water. It didn't really work very well. And I think the reason for that is because of the density of the liquid in the food colouring. It just rose very quickly to the top, and that's not what we want. So make sure that you add your food colouring to some water. So a few drops, and then just stir that around. Stirring this water makes no difference. Right, and I'm just going to darken that up a little bit so that the kids can see it. Also a good tip, do not use yellow. Right, it doesn't show up at all. Any dark colours really, okay, blue, green, red. Qcat calls for red, so I'm using red. Alright, so using my applicator, I put it into the cup and I fill that up like that. Now, what I want to do is get this applicator into the water and cause as little disturbance as possible. So I'm going to start with the container that has the hottest cup, this one. So we're inserting the applicator all the way to the bottom of the container without squeezing it. Now once you've got it there, the kids are going to want to give that a good old squeeze to get the liquid out as quickly as possible. So what we want to do is go very slowly, and we just want to get that colouring out, and as soon as the colour starts to enter the water, now we start to count how long will it take to reach the surface. So counting 1, 2, 3, and I'm squeezing very gently, 6, 7, 8. You can see some of it's rising to the top, 10, 11, 12, 13, 14, about 14. Okay, and taking that out. Now, as I said, one of the things that the kids will do is squeeze the applicator very hard. That'll create a current in the water. That's not what we want. The other thing that they're likely to do is get it in, squeeze the liquid out, and then pull the applicator out very quickly. Now that will also create a current in the water, which again is not what we want. So it's put it in, squeeze gently to get the colouring out, keep going as the colour enters the water, and then when it's almost reached the surface, we can stop. Now, for what we were doing there, we actually were just counting out loud. You could use a stopwatch, you could use some sort of measuring device to make sure that you're measuring the time accurately. As long as the kids, if they are counting in about the same space, we should be fine. So I'm going to darken that up a little bit for this next one, make it a bit easier to see. Not necessarily good science, but So for this cup, this container this time, we have tap water and we have warmer water. Not as hot as the boiled, but still hotter than the other side. So once again, just get that little bit of food colouring off there because that could make a difference. Pushing this into the water all the way to the bottom, squeeze gently and start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and it's just about at the top. Maybe call that 20. Oh, not quite there yet. There it goes. That's about 25. Okay, take that out. See how gently I did that? And the kids can see, right, that stuff moving around on there. Now that might have actually been a little bit more effective had I had that container right over the side of the cup, because we are getting some heat bleed off on this side. Right, but you can see the liquid moving around in there. So as I said, what we're doing is we're creating convection currents. Basically, the heat on this side is heating up the water on this side. Now, as that water is heated up, one of the things that happens to things as we heat them up is they expand. So basically, the water on this side has the same mass, but it's spread over a greater space. And this is the same principle that we use for hot air balloons. You heat the air up inside the balloon, it expands, it maintains the same mass, but it takes up more space. That makes it lighter than the air around it, and the balloon rises. It's the same sort of principle here. This water over here is expanding. As it expands, it rises. That creates a current. So the water rises on this side, and other water is drawn over to take up the space, and that's why that colour is being stuck to the surface, because of that current, that water rising as it is heated. So we had about 15 here, about 30 here, and as you've probably guessed, with less heat on this side, with no change in temperature to create a convection current, we should see this food colouring taking longer to reach the surface. Now that doesn't always happen. but you should certainly see that it takes longer than in our first container. So let's see how we go. Alright, pop that in and squeeze gently. 1, 2, 3, 4, 5, not a lot of movement happening. 7, 8, 9, 10, 11. Look at that. Hardly any current at all. 15, 16, 17, 18, 19, 20, 21, 22. I'm just going to gently pull that out now. Gently pull that out. That is perfect, because what we can see here, look at this, with no change in temperature from this side to this side, that colouring is just sitting on the bottom of the container. It is not rising at all. Now, if you had that happen when you're doing your Qcat, you'd be thinking, great, that is exactly what we want to see. Because what we have demonstrated is that without a change in temperature from one side to the other, we don't have those convection currents occurring. So there's no movement in this water to draw that food colouring to the top of the container.